Hi there. So in this particular section, I thought I'd provide you a little bit of a preview of working with functions and graphs, as well as interval notation and looking at the domain. So closely corresponds to what's in your Math 171 class. So at the top, we're looking at first at, the definition of a function, and you can see here, I filled that in for us here. A function is a unique relationship where each input, there's exactly one output. In other words, for each element in the domain, and domain are your x values, there's only one element in the range, which are your y values. So in the example one, I've just got here for you 3 tables that we're going to sort of investigate, okay, and determine if these are functions or not. Does each element of the domain correspond to exactly one element in your range? So here in example one, the first table, I've got the function y equals 2x minus 6, and I've just picked 2 x values here. I want to just keep it pretty straightforward. The first one, I'm going to substitute in 0 for x, so everywhere I see an x, I'm going to plug in 0. And if I clean that up, of course, 2 times 0 is 0, 0 minus 6, that's going to give me a y value of negative 6. In the next case, y equals 2 times, in place of x, I'll put 1 minus 6. So if I clean this up, then I have 2 minus 6, and of course, 2 minus 6 would give me negative 4. So 1x, 1y, 1x, 1y. So yes, this is a function. All right, let's move on to the second table. This time we're looking at the equation here, y equals x squared. You chose 2 y values here of 1 and 4. So I look at y equals 1 squared, and of course we know 1 squared is just 1. The next one, y equals 4 squared, and so 4 squared equals 16. So here again, 1x gives you exactly 1y. The next x gives you exactly 1y. So yes, this is also a function. Let's scoot on down then to the last example with this table. We're given the equation here, x equals y squared. So in the first example, I'm choosing my 2 values again here of 1 and 4. So I'm going to substitute this in. I'm going to say, okay, well, I know x is 1. So 1, I'm saying here now, 1 equals y squared. So my goal is to solve for y. So to get rid of that squared, I'm going to take the square root of both sides. Take the square root of both sides. So the square root of y squared is just y. But the square root of 1, you ask yourself, what can you multiply times itself and get a positive 1? Well, technically, you can multiply positive 1 as well as negative 1. So we get 2 values there, plus or minus 1, right? Because 1 squared and negative 1 squared both give you 1, right? When you take these y values here, if I were to put 1 squared or negative 1 squared, they would both equal a positive 1. Likewise with the 4 here. So you're saying that 4 equals y squared. Take the square root. So y here equals the square root of 4. What can you multiply times itself to give you 4? Well, that would be plus or minus 2. So in this case here, if you notice, your single x here yielded 2 y's. So you would have the order pair 1, 1 and 1, negative 1. Your x values are repeating. You have the order pair down here of 4, 2 and 4, negative 2. So in this last example here, this is not a function. Because, like we said at the very top, each element of our domain is not paired with exactly 1 y, it's paired with more than 1 y. So now, if we come down here, it just says, okay, well, just kind of now differentiate between which are functions or not. Well, we found out, okay, those first 2 are functions for us, but the last one was not. All right, let's flip it on over. Top of the next page. In example 3, I really just got you practicing evaluating functions for specific values. So I'm going to look at A, B, and C with you, and then actually, I think I'll just look at A and B with you and let you work through C through F. You can pause the video and try it by looking at the solution key that's posted online, okay? So here, if you want to find F of 5, that means everywhere you see an X, you're plugging in 5. So we have negative 2 times 5 plus 18. Every time I substitute, I always like to include a parenthesis. Just that sort of helps you keep things clean and keep your sign straight. So now we start cleaning this up. Negative 2 times 5, of course, will give us negative 10. And negative 10 plus 18 will give us a positive 8. So we can say that f of 5 equals 8. And that would be your solution. Just a little bit of an extension here just to remind you, what does that mean? Well, you just put in an x value of 5 and got out f of x, so you got out a y value of 8. So what that means then is that the point 5, 8 is a point on the given function here of f of x, okay? But again, the answer here is just this right here, f of 5 equals 8, but I just wanted to show you, also state, well, what does that mean? All right, we'll do one more together. In letter B here, it says find f of 0 for this given function. So everywhere we see an x, we'll plug in 0. So you have 0 divided by 4 plus 3. 0 divided by any number is equal to 0. And then 0 plus 3, of course, is 3. So here we can say f of 0 equals 3. And that would be our final answer. And if you were thinking about, okay, well, what's the ordered pair representative now on this graph? That would be 0, 3. Okay. And I think everything else should be fairly straightforward in terms of how I showed my work on the solution key. So I'll let you try those. If you have any questions, feel free to reach out to me. Let's move on down then to your next piece. Functions are often analyzed by their domain and range. As we've already said, domain represents your x values and range represents your y values. Anytime you're looking at a graph and identifying your domain, you're going to be reading your x-axis from left to right. Range, you'll be reading your y-axis from bottom to top, smallest to largest values in both cases, essentially. All right, let's investigate down here in example 4. In example 4 at the top, it tells us, okay, well, it wants us to determine if 0 is in the domain of these functions. So if 0 is in the domain of these functions, then it would be a defined value. So all that we need to do then is substitute and find out, do we get a defined value? So for the first one, I can plug 0 in, and sure enough, I'm getting an answer, right? Because we know that 4 times 0 is 0 plus 7. So f of 0 equals 7. So here, yes, 0 is in the domain, okay? Let's move on to the next one. If we were to find f of 0 here, your very first step, 1 divided by 0, hopefully you recognize that is undefined. You cannot have 0 in the denominator, so in this particular case, no, 0 would not be in the domain. Let's look at letter C. F of 0 here would be the square root of 0, and the square root of 0 is 0. So, yes, it's also in the domain, okay? If you can evaluate and find it in your domain, find a value, then yes, it is in the domain. So, kind of summarize it down here below. From this example, then, we can conclude that functions are not allowed to have 0 in the denominator. You can have it underneath the square root. You could take the square root of 0. You can plug it into a linear function like you saw here in part A. But the moment you try to have 0 in the denominator, you've got a problem. So I'll draw your attention to this fact down here below. When you have a variable in the denominator of your function, you're going to set that denominator equal to 0 and solve for x. These are the values that are excluded from your domain. Essentially, x cannot equal those values. You'll see me here in the video and also in your solution key where instead of setting it equal to 0 and then excluding it, I set it not equal to 0 and then automatically then that is your answer. Okay, let's move on down then to example 5. In example 5, we're trying to determine here if negative values are allowed in our domain. So in the first, and you can choose any negative that you like. So I think I'm just going to choose -1. Keep it simple. Okay, so in the first one, and it's the same thing that happens here. If I can plug in a negative value into each of these functions and still get a logical or legal value for our function, then it is part of the domain. Negative numbers are part of the domain. So for the first one, f of -1, I have 4 times -1 plus 7. So that would give me -4 plus 7. So that would give me a positive 3. So yeah, negative values are allowed there. How about the next one, f of -1? Well, here you'd have 1 divided by -1, and that gives us -1. So yeah, again, that works, right? You plug it in -1, you got out a -1. But how about this last one? F of -1, square root of -1. Remember this square root of -1, you're asking yourself, what can you multiply times itself and get a -1? You cannot, there's not any value that you can multiply times itself and get a negative value. Because think about it, if you were thinking -1, -1 times -1, a negative times a negative gives you a positive. So you're never going to be able to multiply two numbers together and get a negative. Technically, this is referred to as an imaginary number. We'll talk more about imaginary numbers as we move forward in this class, but for now, the takeaway should be that that underneath your radical here, underneath the square root, you cannot have negative values. So here we'll say then no negative values are not allowed. And to summarize that for you here, we can see that radical functions are only defined for positive values. When you have an even root in your function, you're going to set the argument underneath that radical greater than or equal to 0 because you need it to be positive and solve for x. This will be your domain. And it should be noted, there's an extra little special case. If your radical happens to be in the denominator, you'll still set the argument greater than, it still needs to be positive, but it can't equal 0 any longer. It just needs to be greater than 0 and solve for x, okay? So to clarify that, let's move on down then into example 6. They want to know in example 6 which numbers, if any, are not included in the domain for these functions. And you'll notice all 4 of these functions have a denominator. And so from one of the facts that we just talked about, that we learned that you cannot have, your denominators cannot equal 0. So in order to solve these, we would just need to say, okay, well, for the first one, for letter A here, x plus 3 cannot equal 0, and then I would need to solve for x. Anything else would be in the domain, so this would be a relatively quick solve. I would subtract 3 from both sides, right? Whatever you do to one side, do to the other. Always do the opposite when you cross the equals mark. So those 3's cancel out, and so we say x cannot equal negative 3. So we're saying then that our domain is any value but negative 3, all right? And then let's do letter D together, okay? So here, the domain would be any value but where the denominator equals 0. So I'm going to set x squared minus 4. I'm going to say, well, that cannot equal 0. Solve, you want to get closer and closer to getting this x all by itself. So let's take the 4 to the other side. We're going to cross that equals mark, so we'll add 4. X squared cannot equal 4. To get x all by itself, we'll take the square root. So x cannot equal plus or minus 2. It could equal any value but that. So x cannot equal plus or minus 2. In just a few moments, we'll extend this idea a little bit further and talk about how this relates to even further to the domain in terms of interval notation. So if you flip it on over to the next page, you see your interval notation up at the top, and I just talk about up here that your less than and greater than always use parentheses, less than or equal to and greater than or equal to always use brackets. Infinity, when you're talking about interval notation, will always get parentheses. You can't think about it, you can't cut off infinity, so it has to have a soft bracket on it. The next symbol down is referred to as your union. The next one is your intersection, and the last one is like a curved E, and just means element of, okay? So down in example 7, they want us to solve these inequalities, graph them on the number line, and then state our solution in interval notation. And then I just reminded you below here that remember that you have to flip your inequality sign anytime you multiply or divide by a negative number. So I'm going to do 3 of these here with you. And again, it's a good opportunity then, after I do those 3 with you, pause the video and go back and try the other ones before moving on. So let's look at letter A together. So if I want to solve here for x, then I'm just going to, my goal is to get x all by itself. So I want to take 3 to the other side. Solving an inequality is very similar to solving an equation. You just always do the opposite anytime you cross that inequality mark. So subtract 3 from both sides. Cancels out over here, so x is greater than or equal to negative 3. So now let's graph this on the number line. So I'll just put a 0 here. Here's my negative 3. Your inequality sign is, as long as you have it where your letter is on the left, then you can use this technique. So my letter here is on the left. My inequality sign is pointing to the right, so that means I'm going to be shading to the right. This is a greater than or equal to, so I will get a bracket, and then I just shade to the right. Now, in terms of writing this in interval notation, you state now what's being graphed. So the leftmost point here on this graph is negative 3, and then it goes to the right forever, so it'll be going to infinity. The negative 3 will get a bracket, and infinity always gets a parenthesis. Okay. Let's look at letter C. just down here below in letter C, you have 2x plus 7 greater than or equal to 0. We want to solve for x. So the first step, we want to get closer and closer to getting this x all by itself. So I'm going to pull 7 over, do the opposite, subtract 7. 2x is greater than or equal to negative 7. Divide by 2. So x is greater than or equal to negative 7 halves. Now let's think about graphing this on the number line. I just always put 0 as a place of like a marker there, and then negative 7 halves. Then we'll just know it's going to be over here on the left. Greater than or equal to, and my letter here is on the left, is greater than or equal to, so I know I get a bracket. It is pointing to the right, so I'm going to be shading to the right again. So it looks like this. So again, now reading my interval notation, the leftmost point on this graph is negative 7 halves, and then it goes to the right forever to infinity. Bracket and infinities always get parentheses. And then let's do one more together. Let's scoot on over to letter D. I'm going to solve for x. Take 4 to the other side. This is a positive 4. Never go by the signs behind your number. Always go by the signs in front of your number. So I will, the 4 here is positive, so I'm going to subtract 4. Negative x is greater than or equal to negative 4. Remember, if you have just a negative sitting in front of a letter, there's an imaginary 1 there. So I'm going to divide both sides by negative 1 now. You divided by a negative. I'm going to change my color here to really emphasize it. Change that inequality sign. And then now negative 4 divided by negative 1 will give us a positive 4. Letters on the left. So I've got my 0 here. Here's my 4. 4 is going to get a bracket, but this time your inequality sign is pointing to the left, so I'm going to be shading to the left. So I've got my bracket, and then I'm shading to the left, like so. So now if I read this graph from left to right, and I pick out my interval notation, this graph is coming in from what kind of infinity? Really, really small numbers, so coming in from negative infinity, and it stops at positive 4. Negative and all infinities always get parentheses, and our 4 here will get a bracket. Okay, so again, pause the video, try the other 3 that I did not work through with you. All right, let's move on down to example 8. In example 8, I'll just do letter A here with you. It says it wants us to find the values that are in the domain. Find the values which are in the domain of the following radical functions, and write your solution in interval notation. So essentially, it wants us to find the domain of this radical function. And I'm just reminding you again, remember, you can't take the square root of a negative number. So what that means is I need to figure out where this is positive. I need to make sure that this argument underneath the radical here stays positive. So I set x plus 3 greater than or equal to 0, because I can take the square root of 0, okay, and the greater than or equal to makes it positive, okay? So I just solve for x from here. So subtract 3. X is greater than or equal to negative 3. Now, it wants us to write this in interval notation, so if you need to, go ahead and continue, graph this on the number line. So you've got 0, negative 3. Negative 3 will get a bracket. It's pointing to the right, so I'm going to shade to the right. And so now when I go to graph, or now when I state my interval notation, I'm going to say this will run from negative 3 to infinity. Just an FYI, if you want to go back and now check yourself in your calculator, if you go into y equals and type in this function, y equals the square root of x plus 3, you're going to see that it looks something like this. This is just a rough sketch here. Okay, so it looks something like this. So when you're reading your domain, as I mentioned before, you're reading your smallest x value to your largest x value. So this graph starts on the x-axis over here at negative 3 and then goes to the right forever. So that's why we say our domain is from negative 3 to infinity. So these rules that I've been presenting to you are showing you are the algebraic ways to find the domain, okay? I'll let you work through the next little think about it down below that, and then I'm just going to flip it over then to our last page. And essentially on this last page, we're just putting everything together. And I'm going to work through a couple of these with you, okay? So in example 9, it wants us to state the domain of the following functions using interval notation, and then you can check yourself, as I just kind of showed you in that last one. You can check yourself by graphing in your calculator and make sure that what you found by hand corresponds to what you found in what you see in the calculator. So this first one, f of x equals 4x minus 2. We don't have a radical. We don't have a denominator. So therefore, we do not have any restrictions to the domain of this function. So my domain here would be negative infinity to positive infinity. If you think about it, I hope that you recognize that this is a linear function, because this is really of the form y equals mx plus b in terms of slope and y-intercept. And if you don't recognize that at the moment, that's okay. We're going to get there, okay? But if you have that background, if you recall that, then that's really what this is. And I can just a little rough sketch for you. This is what you would see in your calculator. Okay, it would start down here on the y-axis at -2. And then from that point, it's going to rise and run according to our slope. So it's going to go up 4 units, up 1, 2, 3, 4, and then 1 unit to the right. So up 4 and 1 unit to the right. And then it could go up 4 and 1 more to the right. I'm not really precise here, but you can see here, the ultimate goal here also is to show you that this graph goes down and to the left forever, so it's going to the left forever. It goes up and to the right forever, so it's going to the right forever. That's how we're able to say that our domain here is going from negative infinity to positive infinity. Or another way, you could also say it is all real numbers. That's also legal to say. All right, let's move over to letter B. In letter B, we're going to have a restriction on this one, right? We've got a denominator. So this denominator cannot equal 0. But it can equal anything else, it just can't equal 0. So we need to figure out, well, where does it equal 0? So we just simply add 7 to both sides, right? Do the opposite. Cancels out. So we know now x cannot equal a positive 7. So if you're thinking about this in terms of a number line, then you've got your 7 sitting here, and you're saying it can equal everything smaller than that, and it can equal everything bigger than that. But notice how I didn't put a bracket on either one of those, because it cannot actually equal the 7. So if I'm writing this in interval notation, I'm going to have negative infinity is 7, and unite that with the other half of the graph, which will go from 7 to positive infinity. And that would be our final answer for our domain there, okay? And I encourage you to put this in your calculator. When you put this in your calculator, be sure you put the denominator in parentheses, okay? So 1 divided by, and then your denominator in parentheses. That's important. All right, let's move on down to, let's look at letter C. Letter C, you've got a radical, right? And so radicals have restrictions. What's underneath that radical? X plus 6 has to stay, hopefully you agree, positive, so greater than or equal to 0. And we saw for x here, subtract 6 from both sides, so x has to be greater than or equal to -6. And then from here, so now, you can graph your number line. Think about, okay, well, you've got your -6 over here. It is pointing to the right, so we're going to be shading to the right. Again, I encourage you can put it in your calculator as well so you can see this graph. So -6 to infinity to make that connection for interval notation, okay? And then the last one I'd like to work with you is letter F, because that can be the trickiest. Notice how in letter F, I've got the denominator, and in that denominator, I have a radical. So what we know about this then is that this denominator, it can equal 0, but it also has to stay positive. So here we need x plus 9, the argument down there, we need that x plus 9 to stay greater than 0. Okay, this will allow us to figure out what our domain is. So I'll just subtract 9 from both sides. And so x is greater than -9. Okay, and then our interval notation then would go from -9 to infinity. Parentheses on both, right? Because since it's greater than -9, I'll do my number line here for you. So here's my 0, here's my -9. Since it's just greater than, you get a parenthesis, and then it's pointing to the right, so a shade to the right. Again, that technique of the pointing part of your inequality symbol, that only works if your letter is on the left. Okay, so letter has to be on the left in order for that technique to work. Okay, all right, let me know if you need anything. Thanks a lot. Bye.